Okay, so now we're ready to set up the routes that to go ahead and do all the routing for the copper traces through the PCB that the electricity will actually flow down. And up here in the menu, we have an option for auto router, and on very complicated designs, I'll go ahead and use that. Usually, I like to try to do it by hand first if I can. And this one's not too bad, so I'll go ahead and do this by hand. Sometimes the auto router will just fail. And one thing, before using the auto router, it can really speed up the process and help if you do at least one line through. So if I'm going to use auto router, I'll usually do like the ground rail all the way across or something, and then hit auto router, and that speeds up the process and helps out. Uh, I think it's a depth first search, so it goes through and checks every possible combination, which can take quite a while sometimes. So on something simple like this, I like to just route it by hand. So I'm going to start over here on this left side. This looks a little easier. So our ground and 5 volts don't cross at all, so that shouldn't be a problem. We could put them both on the same side of the board. Uh, these go across, but they're just straight over to the pins. There's nothing else going on, so we can put one connection on the top layer and one connection on the bottom layer. So I'm going to click over here so we have the top layer of copper and the bottom layer of copper. So I'm going to start with the top layer. So we just select the layer and then go over to our track. And any place we have a network, we can go ahead and make that connection. So our ground can trace through here and connect to the ground in there. So that connection is formed. Notice that the network that was shown is inside there now. And then for the 5 volt, I'll just come up and over. Well, that's not going to work. So I need to come up a little to begin with and then over. And you can see those are well clear of each other. It looks like this one's going to try to cross that, so I'll put this one on the top. I'll come up first, come up a little ways, and then come over to make that connection. And then for this last connection, come over to the bottom layer and just kind of trace through there. And it's on a completely separate layer of copper, so it doesn't matter if it connects to anything, but definitely can't have it going through other holes. So you need to come up a little and then over to make the connection. And that's basically the process. Just kind of look at the connections that need to be made and find an actual route for the copper to go through there where there won't be any like two red lines can't cross. If we have to cross, make sure when lines need to cross, make sure you do it on the different layers of copper like that. And then it's just jumping back and forth between the two layers until you get all the connections made. And once all that's made, just a thorough inspection to make sure everything's connected and no shorts. But this side was fairly easy. I don't think the other side will be too complicated, but let's go ahead and start working on that. And as I look at this, it looks like most of the crossings happen right here. So this is a big deal. So I'm thinking if the ground is all on, say, the bottom layer, then all of these can cross on the top layer and we should be fine there. So I'm going to go ahead and set up the ground. I'll go to the track tool and bring the ground over here to make a connection. Well, maybe I'll go over a little and then up to make the connection, something like that. And then all these grounds, there's nothing crossing, so I'm just going to stay on the same side and come straight across one little rail there. So that gets the ground, and then all these signals we can set to cross above that. And before we do the ground, I want to go ahead and bring the 5 volts in and trace that around, and then I'll do the signal lines last. So I'll go ahead and do that on the bottom layer and hopefully be able to do the signals all on the top layer if the ground and the voltage are both on the bottom layer, because we can see those lines are nowhere near each other. So I'm going to come out from that. And we don't want to touch anything that we go through, so we don't want to touch another one of our tracks or any of the holes. So we can just come down and set up a route through here that will avoid contact with anything else. That got a little off square, but that can be adjusted afterwards. Bring that over. That looks like it connected okay. Bring that over. Oh, that one's going to try to connect there, so I'm going to come up a little. And then over to here. So that got the 5 volts connected to everything. There was a couple that looked a little like they had a weird twist to them. So I come in here and zoom in. Yeah, we can see that twist up unnecessarily. So I'm going to bring that down and try to make that a little more square. And we can just click and drag those points around to get a nice shape that avoids any crosses, avoid any other holes, and try not to get too excessive. But remember, this is a printed circuit board, so what happens is a machine cuts a groove, then sprays a chemical in there, and then copper sticks to that chemical that got sprayed in there. So it's really no trouble to do complicated shapes. We just have to be careful. We're restricted to the angles we can turn at. We can only turn so sharply at so many angles. But now we can move on to these last few connections. And after staring at these intersections here for just a couple seconds, quickly realized that we won't be able to do all of them all on one side or the other. So we're going to have to switch sides. So I think I'll bring the signal line all on one side, and then the resistor will have to switch from between the bottom and top sides in order to get across everything. So to cross the 5 volt line and the ground without switching sides, we can just draw these signal lines on the top layer. So move to the top layer, get the signal here, and again it has to come across and not avoid any holes or anything like that. So I'll come up like this. So that's a little too close to the hole. So I'm going to go ahead and put the line here, but I'm going to move it up very shortly here. So I'll come up and straight over to D7. So that got all the way across there, but it's awful close to that hole there. So I'm going to click here and grab the drag points and bring that up where it's well clear of that hole. There we go. And kind of that same process for all of these lines. So I'm going to go up, make sure I'm in some nice empty space, come over, up, and over again. And once again, those last little drag points, I can kind of drag that up and get something a little straighter. And that's all there is. Once everything's connected, just come through and draw the actual route that the copper will go for to make these connections. So we can do the same thing on our other signal lines. And we have that network connection so we can see where it needs to go. So I'll come up, over a little ways, up till it's about straight in, and right in to make that connection. And same thing on the last one. I'll come up, over to stay well clear of those holes, then just up and over to make the last connection. So this is a fairly simple circuit board, but you can see there is a little bit of thinking involved to avoid all the routes, because now on this last one, to get to the pull down resistors here, well, if we tried to go all the way on top, we'd hit that. And if we tried to go all the way on the bottom, we'd hit that. So we're going to have to switch sides along the way. And, well, actually, we want to be careful about how many times we switch sides. So it might be a good idea to go ahead and move this red line up here past the blue line. So we can go over, then bring this up to, say, up here somewhere. And try to find a route that minimizes our crossings. So I'm going to stare at this for a minute. Let me go back to where I was. And I'm going to stare at this for a minute and see if I can figure out what the best, the minimum number of crossing sides will be here. So I'm just going to start in at the top here. This spot's obviously going to be a problem. So maybe we should bring this down and try to go underneath of those holes. That way there's enough space plenty of space to jump across those lines. That'll work. And now there's not a top and bottom right next to each other, so that's definitely something you always want to watch out for. So this one I'll keep like it is and maybe move this one up to match that flow a little bit better. And I'm thinking to clear out this area, it might be better to come over and then up. So we can just select that, and instead of coming straight up, I'm going to come straight over to begin with. And remember, these are on different layers, so the yellow is just painted on top. Then the red is embedded in the inside of the green or whatever colored plastic. And then the blue is also embedded, and then the gray holes here go all the way through. So they're all on different layers, so we don't have to worry about going under the paint is the main thing. So that goes up, and let's see, I'll bring that a little kind of close to that one. Now I need to come over and up, so I'm going to delete this middle segment here. When the line's highlighted, we can click on just one segment of it and delete that, and now come through and we should be able to snap right to the end of that line, bring that over, and back up and snap right to that line. So we can just delete a segment. So highlight a segment, and with it highlighted, or I meant to highlight an entire track, and then when it's highlighted, we can highlight and work with delete just a single segment. So I think that'll make it a little easier to get across those. Now these two are obviously going to be okay, and I just noticed that this one, if instead of coming up and over to came down and around this hole, we wouldn't have to cross at all here, which means the only place that crossings become an issue is on this last channel. So I'm going to make that change. If I select that line, I'll go ahead and delete that whole thing. And on the bottom layer, I'm going to come down, then over, then up, and over again. And now that one doesn't necessarily have to cross anything along the way. And obviously these would be okay just on one side. I'll just throw them in on the top here. So you can bring this one up to make sure it's well clear of that hole, over, and then back down to get over to the connection there. Then it'll flow through a resistor back to ground. Then this one, all it needs to do is cross something on the bottom layer, so we can again come across it on the top layer. These only cross things on the top layer, so we can jump down to the bottom layer and go right underneath all of those. which leaves just one signal line left. So we're going to have to come on the top layer past this bottom track. Then we'll come through the board, go through the board, and on the bottom layer to go underneath those tracks. So I'll go to the top layer, the track, and bring it up to somewhere past that blue line. So that looks good right there. And then right click to release the tool. And in order to go through the board, well, obviously a hole goes through the board, but we don't have to make any connections. So just to connect our tracks through the board, our tool is the vial tool. So we'll grab a vial and zoom in here and snap this right to the end. Notice the image looks, and then right click to release the tool. The image looks like a hole, just a lot smaller. So that's the one that'll connect the top side, a track on the top side to a track on the bottom side. So we'll come back over here, snap to that vial. We're on the bottom side now. So we can come over and staying well clear of that hole, then come up and make our connection there. Right click to release it. And I believe all the connections are made now. Fit in window. Oh, that wasn't really the view I wanted. Try to get a good view. So now we want to do kind of a thorough inspection. But I have some tools set up from previous projects to help with inspection. And there's also some inspection software that can be easier to look at the things on than the drawing software is. So let's look at a couple of those. But we could inspect it here. And once all the connections are made and everything looks good, and if you want to, over here, visible grid, we can turn the grid off and kind of see the lines better. We kind of look around, make sure everything looks good, because we have to work with images and make sure everything looks okay. And once you think you're ready for it, this button over here with the G, that's what we'll click to generate our Gerber files. Oh, I have to save first. Oh, and I should probably point this out. If you're going to inspect here, notice the eyeball button, so we can turn layers on and off to help see what's going on. So we can turn like all that label printing off to actually see the traces and holes. And so I'm going to download the Gerber files and look at that on some other software. We're going to talk about that in a second. Once we're ready, we can save the project, and then the PCB fabrication button here, which I think we also have here. We want PCB fabrication file, which is called a Gerber file. So go ahead and generate the Gerber. And this is what the kind of has it set up. And you can see this is set up with to go through JLC PCB. $16.10 for 10 of them. Their smallest order is 5. It's a little bit more, but if we order 5, that's $10.10, so about $2 a piece. If we order 10, what is that? $1.60 a piece. It's not too bad. So $1.60 a piece for the printed circuit board. And when we're ready, we can just hit order at JLC PCB. I've worked with that company a few times and been very happy with them. There are other companies, so we can also just generate our Gerber files and send those to a different factory. I've dealt with this company a few times. They produce high quality PCBs. $1.60 a piece isn't too bad. So when we're ready, we can just hit order and then OK, and this will come over and add it to a cart and be ready to check out from this site. which seems to be taking a moment to load. So I'm going to pause the video while the site loads. And it gives us a little preview here of what the top of it with the labels printed on there, and all the holes are going to look like. And here's the back side. And it could have been a little bit cheaper if we would have gone with a square board, because all this really would have fit over here. But I went ahead and put the handles on there for holding while testing, because the case is probably going to be the last thing that's made. So having that odd shape, something that's not square, there's an extra fee on. So it would have been $12.20 without that. But now looking at this picture, I suddenly realized something we forgot. There's going to be a plastic case eventually, so we need some screw holes to mount that in the plastic case. But there's some other inspection that's going to do, so I'm going to come back and do this the last step, and let's look at some of the inspection things. And well, first off, let's go throw some holes in here so we can mount it in a plastic case eventually. So we'll come back and do this at the end after we're done with the inspection and everything. So cancel out of this. And so here, the pad, that's the hole that goes through with just a little bit of metal surrounding it so that we can attach solder to it when we connect our pieces. We also have this hole here, which is actually the attachment hole. So we just drag that in, find a nice empty spot where we'll be able to mount it securely, and just click to put that. And I can't remember the size screw holes I like off the top of my head, so I'm going to pause the video and check an old design that I know has the screw holes size that I prefer, because screws, there are lots and lots of sizes of screws, and I've found that some are easier to work with than others, especially when we have a bunch of other stuff going on the board to get it started with fingers and all that. So let me check the size of screw holes that I like to use and be right back. Okay, so looking at old designs wasn't very helpful, so I actually had to go over to the shelf and grab the screws I like and look at the label on the box. And it's M3s are the ones I like to use, which have a 3.2 millimeter diameter. And then a 4 millimeter head on them. So they have a nice wide screw head to it to hold things in place. They're plenty long enough to work with, and we don't have, it's not one of those microscopic screws that you have to have tweezers to work with. So now that I have one of those, I'm just going to select that. Is it selected? Copy and paste, and find a good spot to put it, clear of all the electronics, and then kind of find a spot to secure each one of our corners. Anywhere down here will work, so somewhere over there. And I should turn the grid back on. Yes, turn the grid on, that way I can line this up. Want some symmetry to it, I guess. I mean, those are screw holes, so we're going to build our case to match that. So that works. So now if we generate the Gerber files again, oh, have to save first. So save, generate our Gerber files, which is under fabrication. Go ahead and generate that. Oh, now we can see there's screw holes to attach it. And I want to do a little bit more inspection before I do this. So I'm going to go ahead and download the generate Gerber files and use a couple of tools that I've set up in previous projects for inspecting that. So generate Gerber, and then that'll download a zip folder. So let's go look at the files we got from that. And yeah, Gerber files are the ones we need to send off to factories to print the circuit boards for us. And now that we have that downloaded, we could send that to any factory. It doesn't have to be the one that provides this design tool, online design tool we used here. So let's go look at the inspection, the software tools I have in mind for inspecting this and making sure everything looks good before we place the order.